Today's webinar is on our eRAVA program. That is the exida Remote Actuated Valve Assembly. And what that is, it's really talking about final element certification. You're used to us talking about a device or a valve or a solenoid certification before, but now we're going to take it a step further and look about when the remote actuated valve assembly, when everything is put together, when that valve, the actuator, the solenoid, and all of the other accessories are put together, how they interact with each other, and the certification for the assembly itself. For those of you that are not familiar with myself or exida, my name is Loren Stewart. I'm a CFSE here, and I'd like to welcome you to our webinars. I've been working at exida for about over 7 years now, with a lot of our mechanical customers, helping them achieve device certification for their valves and their actuators. But now we're going to take it a step further, and I'm really helping with the eRAVA campaign on how to take the same attention to detail and same rigor that we give the devices on how they're assembled and put together. In case you're not familiar with exida, we do everything, the complete supply chain of functional safety. So if you are the OEM making the devices themselves, putting them together, the whole way through to the end users using the products or maintaining the devices, we have experts, tools, consulting, certification, all sorts of ways to help, and training to help make your functional safety life more secure, more reliable, and easier. I like to say no matter where you are, where your products are going into, where you're buying your products from, whatever you need in functional safety, alarm management, or cybersecurity, we have experts close by, and this map isn't even the most up to date. And we're continuously opening more offices. But it's no matter where you are, we have experts in the field close to wherever you need to be. And then the final thing about exida before we get into why you're really here, I always like to let all of my customers know to keep up to date with what we're publishing. exida, excuse the pun, but we really like to be an open book. Everything that we are researching, all of our processes, our procedures, a lot of our templates, our databases, all of our information we publish and we get out there into the real world, because what good is it doing if we think we're learning this ways to be the safest? What good is that going to do if we keep it to ourselves? So we do a lot of things like these free webinars and free blogs and free white papers that you can download. We go to conferences, we speak at technical conferences and standard committees. And we have all of these books, but always keep up to date on and keep tabs on what we're doing and what we're researching, because we're always getting that out there. So always check back to exida.com and see what is the most recent and what we're doing. But let's get into why you're really here today, and this is that eRAVA final element certification. This all came about because no matter if you're a plant engineer or a person that has just worked in the field, or just someone that's familiar with functional safety and final elements, it's kind of common knowledge that even though you buy a SIL certified product and you check a box, you put it into your system, that doesn't necessarily always mean that it's going to be compliant with IEC 61511. And it definitely does not guarantee reliability and safety in your final element. There's a lot of times where there are a check-the-box mentality approach being applied, and that's not translated well into the real world. There are failures, there are accidents, and downtime, all because of this. And we wanted to find a way to solve that solution, or at least solve a part of that, the problem that we saw, and provide a solution for it. So in this webinar today, we're going to show some examples of field failures that were seen in real life, and how they can be avoided by not just looking at devices with that rigorous process and rigorous procedures and rigorous documentation, but also looking at how those devices were integrated or how they were assembled, and having that rigor and that fine-tooth comb on the assembly process as well. This, in result, can decrease those accidents, those failures, that downtime that we're seeing, and also reduce realistic failure rates for those remote actuated valve assemblies. So, and we'll get into all of that upcoming in this webinar. If you have questions throughout the webinar, please feel free to ask them in your panel. I'm not the best at taking time to stop throughout the webinar, but I will take time at the end and answer any questions that you may have. So if you're familiar with process safety, you may have already seen this study out. It's an older study, and it was actually redone, a second edition. All of the same principles were kind of holding steady, and even now it's still not the most up to date, but once again, the concepts are holding steady. HSE, the Health and Safety Executive in the UK, did a study showing accidents in industrial control systems, and wanted to look at the number of different cause categories that brought these failures. And it was shocking, especially at that time, to see that so many of these failures were done or credited because of 44% because of specification, another 6% because of installation and commissioning, and another 15% with design and implementation. That is a large chunk of these accidents and these failures that could be possibly prevented with possibly better methods, better documentation, or better assembly or integration. What some people feel is a challenge, where this all comes to play and where this all falls to, is the fragmentation between the OEM manufacturers of the devices looking at IEC 61508 and your end users looking at IEC 61511. There's a lot of times the OEMs are taking credit for their devices and putting that out in the world. The end users are looking at more than that, just device, however. And there are sometimes fragmentation or finger pointing between the two. And what happens is there's this, not necessarily a gap in the standards, but a gap in the way the standards are relayed in the real world. And a lot of things, such as the assembly of your final elements, things like looking at torque, the drivetrain components, the bracketing, the mounting, the coupling, looking at the entire final element assembly, testing and validation and verification, that sometimes gets left in this no man's land. OEM manufacturers are assuming that the end users that are putting these pieces together are going to be doing this. And the other hand, the end users are assuming that they can just buy something put together and this is being taken care of for them. So although there's not a gap in the standards per se, there's a gap in the way we are applying the standards in the real world. And this can fully be covered by IEC 61508, and that process and this gap can be narrowed. And that's what we're proposing to do with eRAVA. Look at some of these things falling in this no man's land, and take credit for them. If you're already testing and looking at torque, if you're already designing a bracket meant for your final elements and not just putting a piece of scrap metal on to hold things together, you're already doing some of these things that people are throwing in that no man's land, and you need to be taking credit for doing those as well. Anybody working in the process industry or in functional safety knows the consequences of accidents. So I'm not going to spend time on this. Everybody knows that if you have a catastrophe, if you have a catastrophic failure, we're not only just talking about risk to loss of life or personnel in the working environment, but also the community, damage to the environment, damage to your reputation, fines, cleanup costs, market share and shareholder value. All of these things compound, and these things can really add up to a lot. So if we can minimize this risk by looking at the final element assembly together and not putting things in that he said, she said, no man's land, we can then make our current practices stronger and take this level of risk even down further. We met with a lot of end users globally to see what they wanted, what they needed to see from this final element certification. We also met with a bunch of manufacturers to see if some were going above and beyond, what they were doing, and how they were proving this. And we developed a certification scheme with different levels to show our final element assembly. We're going to dive into how these pieces, whatever pieces are put into the assembly, whether it's the valve, the actuator, the volume booster, solenoids, we can add in anything you want. But we're going to take that same look we normally do at that valve, that same look we normally do at the actuator, and look at how they're being pieced together with the same rigor. We want to look at the design, we want to look at the testing, the verification, the validation, and make sure that the same detail was put in how they're being assembled, how they're being integrated before shipment, how they're being tested, and not only that, but what information you're giving the customer as a full assembly. Are you taking in consideration the proof test for the full assembly, the proof test effectiveness with the proof test procedures? And so, as we say, some people are arguing that there's some sort of gap between IEC 61508 and 511 for covering that no man's land. However, if you apply the standards intelligently, there's not. It can be covered by IEC 61508 and 511 if you take that same rigor and that same look at the integration rather than the individual devices. And what this looks like, instead of just getting a certificate from a valve, a certificate from an actuator, a certificate from a solenoid, adding the three together and putting that out there, this is going through that same rigor for the valve, actuator, solenoid, and the assembly. So you will have that fourth certificate analyzing all of the system together, looking at the failure rates for all of the components in it, the proof tests for all of the components in it, and the systematic capability for everything together. When you look at the assembly or the integration with that much rigor, what happens is you can start to notice improvements in reliability, improvements in safety, and improvements in failure rates. How do we do that? It is because we have our stress and strength diagrams here. Failure rates come and failures come from when stress overtakes your strength of your device. And that's when a failure is going to occur. So normally, that's this area under the curve here. And that's going to be your typical failure rates in your typical stresses, in your typical strengths. However, when we look at something with eRAVA, we're going to be taking a closer look at the entire final element process, the entire design, and that's going to reduce the chance of any design fault at the assembly level. So instead of just looking at our typical strength curve, we can narrow that down because we reduce that chance of those faults. We reduce those uncertainties. So thus, reducing that curve also reduced the area under the curve, making lower failure rates for doing those above and beyond things. If you, once again, do a step above and beyond, you can even reduce your failure rates more. How do you do that? It's with a program we have called the SRA, and that's the Safety Reliability Analysis. That is kind of, if you do anything above and beyond, this is where you're going to really shine. Say you make an O-ring that's shaped differently to reduce binding, or you make a spring that is specially designed for this application in this device and it has super strength or whatever it needs to be. What did you do to make your products better? And you can't just say my product is better because I think it is. Show us the documentation, show us the FEA, show us the testing and the validation. Show us that you added strength into your product. If so, once again, instead of tightening the curve, it will actually move that strength curve up. Once again, lowering the area under the curve, lowering those failure rates. Then, if you want to do everything you can then also look at an application review. What is that? That will be when we look at what this final element assembly is actually going into. Do you know the environment? Do you know the application? Same thing we did with the strength. Once you know more of those details, you're taking out that possible area for design faults and that area of uncertainty as well, narrowing those curves. Once again, narrowing the area under the curve, showing the difference in your failure rates. And as you can see here, I highlighted that light gray area was the original failure rate under the curve area. And if we apply the eRAVA, the SRA, and the application review, now we're talking about that little area in black. That's going to lower your failure rates of this entire final element assembly because of all of that uncertainty that you've taken out. How do you do that? Well, it's going to be a lot like our regular certification projects if you are familiar with it. We dive into what we call a safety case, and it has all these top level requirements. Each top level requirements are then going to have different requirements and from the standards and different design requirements in each of these. So for example, we can take a closer look at the design verification tab. And under design verification, you might have a verification plan. You might be looking at the fail direction. You might be looking at the long standstill times, the fluid characteristics, the operating temperatures. You might be looking at torque. Each one of these categories, say we take that closer look at torque. Will then also be broken down. What type of torques did you look at? Did you look at the break to open torque? Did you look at the end to close? What about your mast? And then we're going to analyze each of these on a low, medium, high ranking. So take, for example, that break to open force. A low analysis might be that you used a simple calculation or a torque table based off of simple calculations, and you did your analysis, you followed the table, you checked that the torque would be fine, and you moved on. A medium level of analysis might be that you did that torque table, but you considered some things that were going on in the application, and you made a correction factor for that. And then maybe your high level of analysis for this would be you did a complete dynamic torque analysis, or you used some type of software or tool to do this torque analysis for you. So for each of those requirements and those subsections, we're going to have different ways you can prove or different ways you can show how you're meeting these requirements. We're going to do that for each of the requirements tabs in the safety case. Once again, just like torque, we're going to look at mounting on that drivetrain components. If you've done an FEA, if you've looked at mounting, coupling, alignment, your fasteners, if you've taken into consideration all of these. And once again, we will do the low, medium, and high for each of these. When we are doing the process, we also, once again, it's the same sort of process as your original certification, device certification. We do the initial document review. We will do an FMEDA. And of that FMEDA, we look at each of the individual devices, that valve, that actuator, that solenoid, that volume booster, controller, whatever you may have in there. And also do an FMEDA of all the parts put together as an assembly and see how they work together. Could they interfere with each other? Could they interact? If you already are using certified devices for your valves, your actuators, your solenoids, all of those parts, you don't have to redo these FMEDAs. We'll just do the FMEDA of the assembly or the integration and move on from there. Same with the safety case. We will need to evaluate each of the devices going into the assembly, but if you're already buying certified devices, we just need to look at the assembly itself and the integration. Just as a normal device certification, we'll want to do an on-site audit, take a tour of the manufacturing location, witness a validation test, or and then we'll have our second assessor see if they agree with this first. And at the end, you will receive your assessment report and your certificates, your certificate just as you would for your device certification. There are different levels of this eRAVA certification. And you can kind of remember how the curves were. You can look at just the eRAVA. You can look at a HIPS type approval. You can look at an eRAVA, an SRA, and the whole application in that stress curve as well. For each of these, you'll have a certificate that you are presented at the end. And this last one, when you're looking at the application as well, you will not only be the IEC compliant, but you will also be WIB compliant as well, and meeting the requirements in that standard as well. And what does it look like? Well, the output, or what you're going to receive at the end, it looks a lot like the device certifications, but instead of getting each valve, actuator, solenoid, volume booster, and putting them together, your customer only needs to look at one certificate. This one certificate has all of the information you possibly need. It gives you your systematic capability, your random capability, your SIL level, the hardware fault tolerance, Route 1H, Route 2H, and on the back, the greatest part, you have a table with the failure rates for all of the devices put together with the diagnostics with all of the devices put together. There's no more, you know, calculations for your customers to be piecing together. It also will let them know the assessment report number and the safety manual number so they can go back and get more information if they need any particulars. As we said before, if you are doing this eRAVA, if you're doing the SRA and the application review, that has doing those things above and beyond that most people are doing now is going to give you those lower failure rates on that certificate too. So it's not just adding up that valve, that actuator, that solenoid, but when you're adding that amount of rigor to the assembly, when you're looking at torque, when you're looking at proof tests for the whole assembly, it's not just going to be 1 + 1 + 1 = 3. It's going to be less than that. And once again, that's going to make your customers super happy. They don't have to do as many calculations. They don't have to piece all of these certificates together. And you're going to give them a lower failure rate for the whole package. How is this also presented? We like to get that information out there as much as possible. The certificate and assessment report will be on the SAEL, which is the Safety Automation Equipment List. This SAEL is what a lot of end users go to look up their devices. Say they know they need a SIL 2 capable or SIL 3 capable valve, they can come to this list and have all of the devices right there for them. On the SAEL, we will have a special tab for these eRAVA projects, and the end users can come directly there and know this is an entire solution for them that they don't have to piece together, and it will be listed here. It will also be in SILentia as well. So instead of your customers having to individually pick all of the pieces, they'll just be able to pick your package solution. And we also offer a lot of support, and along with the next steps. After your certification, we don't just stop there. As I mentioned in the intro slides, we publish a lot of white papers, webinars, blogs, case studies. We go to conferences. We enter this stuff into trainings, and we have magazine articles. We get this information out there, and we will be working with you to get that information out there as well. If you once again are going above and beyond already, you need to make that clear to your customers, all of the great things you're doing, and take credit for that. So we've reached the end of the webinar, and I did not stop for questions throughout. Once again, sorry about that, but I'll take some time now and answer them. And if you think of any questions later on, please feel free to email me. My email address is there. There's some other links for our books, our white papers, the webinars. If you want more information, constantly check back to our website because we're always publishing more and more and more. At this point, we don't have any questions. Thank you, everybody, for joining today. I really appreciate it, and I look forward to seeing you again.